Greetings, this is Artie from Artifact Electronics. In today's episode we'll have a look at this quartet of Krohn Hite function generators. It's a Model 1200, or they are Model 1200As, linear sweep function generators. I picked these up at University Salvage, and I've already had a quick look at them. They all seem to work, electrically that is, but they came from an extremely dirty environment or were stored somewhere, so that I can get them to do mostly what they're supposed to do, but all of the front panel controls are very dirty. We got dirty pots and dirty switches over here, and this video won't be so much about repairing them, but rather cleaning up the controls so that we can see if we can get these things to work properly. They had a whole boatload of these available, but most of them weren't in very good shape. They had damage on them. The radio buttons wouldn't work, and so what I did was I picked out the best ones I could find. I made sure they turned on, and make sure that the power is on but no further testing done comes true. And on the radio buttons I was pretty careful, because if those things, if they break, it can be a bit of a pain in the butt to fix, if you can fix them at all. So here you go, we got the four that were in the best shape, but we got really, really dirty controls on all of them. We have scratchy pots. We have mechanically all of the radio buttons engage and work properly, but the contacts inside them are oxidized and or dirty or whatever's in there, and they need to be cleaned, because, for instance, when you select certain waveforms on this, nothing comes out of it, and if you just push the button in slightly and find just the sweet spot, then sometimes the waveform will pop up, but the minute you let it go, no dice. So let's have a look, see what needs to be done to these. This is what things look like inside. This is the bottom of the unit. Well, first we can see a bunch of garden variety pots over here, and those are the easiest part. I mean, what these things look like is like this, and what you have is right behind the solder tabs, we have a big open slot over here, which the carbon track is right behind this, and because of this slot, dirt can get in easily, and if you look really close, you can actually see the wiper over here. So that's not good. Dirt can get in and they go bad or don't function right. But the good thing about it is you actually have access to the inside. You can spray it with contact cleaner and work it back and forth vigorously. And if that fails to give you any results, you can bend back these tabs over here and actually remove the back part and gain full access to the carbon track. Now, of course, if the carbon track is damaged, even nothing will help it, because the carbon is essentially worn off and it won't be functioning as a resistive element anymore, and in that case they definitely have to be replaced. This is a common occurrence on musical instruments, where people during a live performance basically tweak these pots continuously, thus wearing off the carbon track, and no amount of contact spray or cajoling will get them to come back to life. Now these, the ones you see here, shouldn't be used that heavily in real time, especially since it's a sweeping generator. I mean, you do frequency adjustments maybe, and you tweak the output amplitude and stuff like that, but they should not receive constant use throughout they're live. So there's a much better chance that these pots are just dirty. And the way to fix them is to get your contact cleaner nozzle or tube into this open slot over here and just spray a lot of contact cleaner in there. Work the controls back and forth several times, let it dry out, and repeat. Then let it dry overnight and test them. So all of these pots can be, we should be able to fix those with the procedure I just outlined. The open slots are of course right under the PCB, so you got to kind of snake in over here. Make sure that the slot faces upward, so you're putting the unit down like this, and then you just spray stuff into here, working back and forth, and hope for the best. Now the odd man out as far as pots are concerned is the frequency adjustment knob, which is this pot over here. It's an Allen Bradley pot, and it is sealed. So what that means is obviously when they're new, they're sealed, they're not supposed to get any dirt inside them and work forever. They still have carbon tracks on them, you can wear them out, but dirt shouldn't be an issue. But the way dirt is, it makes its way in. It's not perfectly sealed back. It's not perfectly sealed back here, and the shaft, I mean where the shaft meets the body of the pot, dirt can theoretically, not theoretically, but practically get in there, because a bunch of these pots are dirty on my instruments, and the sealed aspect of them works against you at this point because you can't spray them down. There are no open slots here. You cannot remove this back plate, even though I played with some of the tabs, bending the tabs back, but they're still crimped onto the main body. You cannot remove them. And so what happens is the dirt's in, and you can't get it out. The only way that I thought of, and I'll illustrate it with a non-sealed pot, but the shaft assembly is the same, is getting some liquid, some contact cleaner over here where the shaft enters the body of the pot, let it sit upright, and hope that the contact cleaner will actually seep in through here, through the bushing. But that, even though theoretically it kind of made sense to me, but it does require you to spray a lot of contact spray in here, because what you're counting on is that the stuff pools in the body on the bottom, and thus covers the carbon tracks and cleans them. But the dirt and the leftover contact spray have no way of getting out of it again, because you would think you turn them upside down and things start flowing out of here, but no, that even on a regular pot like this, you cannot get through. So what I'm getting at is that the Allen Bradley pots, I think they need to be replaced. I mean, I did try to do what I just explained with no noticeable effect on the pot's operation. So the pot has to be replaced, and I looked around. Pots are available, but surprisingly, or not surprisingly, but most of them are used. Buying used pots to me is like buying a used phonograph needle. Why would you want to buy a used part? I understand in a real emergency that if that's all you have and it's guaranteed to work, yes, but a part that obviously degrades with usage, you probably want to stay away from used parts. And also these things aren't cheap. They're around $10 without shipping for a used piece, and I don't think that's a good idea. I finally did get replacements, which are physically very different. These are just your plain cheapo pots. They're much smaller. They have a knurled shaft, whereas the Allen Bradleys have smooth shafts. But I think it'll work. It's a 2K pot, and 2K is not a very common value, so they're not widely available. But we'll see. We'll take out one of the pots, we'll compare them, and see if the pot physically fits in its place, and if we can attach the frequency knob properly to it, and then we should be okay. Last we have the push buttons, some of which are radio buttons, i.e. it means they're 1 out of 3. For instance, the waveform control here, obviously they're hooked together and only one of them should be pressed down at one time. The frequency multiplier is the same thing, which are these 3 knobs. And then the other 2 or 3 knobs are just regular push button on-offs, a DC offset switch. We have a, what does that say? Times 1K for the sweep, a sweep scale button, and the sweep enable button over here, also regular push button. The problem with these is that the contacts inside don't make contact properly, and just like with the sealed pot, there's no obvious way to get inside of them, to spray them down. Tried the shaft method, sides here, it didn't make any difference. So I kind of looked at these with the contacts sticking out through the slots over here, and I noticed that the slots in the plastic piece, this is not a snug fit. There is slight space around the contacts and the plastic piece. So what I did with those is I laid this flat, and I gave it a good spray of contact cleaner all along these contacts, hoping of course that the contact cleaner fluid would make it through the gaps between the contacts and the plastic and actually make their way to the contact strips inside. And then of course exercising the buttons a lot of times, just like what you have to do with pots after spraying them. And I think I met up with success because the pots did seem to start working. No, not the pots, the buttons did seem to start working. And again, I let it sit for a while. I repeated after an hour, and then I let the whole thing sit overnight. And now's probably the time to have a look at that frequency pot replacement. So here's another one of the units where I took the frequency knob off and just took the pot out. Well, here's your sealed pot. You may be able to see that I messed with the tabs a little bit, but bending these tabs back did not free up anything. There are no open slots underneath the contacts. Can't get in. So again, the only way to access this seemed to be through the shaft, but that didn't make a difference. Now, what some people have tried, and I don't think it's a really good idea, but they've drilled small holes or a hole into the body over here, then sprayed it with contact cleaner, let it dry, drained it, and then closed up the hole. The problem with that approach is if you drill this body, you're going to get metal filings to fall inside on the carbon track and cause all sorts of havoc. If this doesn't work, if a sealed pot stops to work, you need to replace it. So I told you before, I looked around, didn't find anything, so I ended up getting myself some plain vanilla 2K pots. Obviously the shafts look a little bit different size. Also, this one's smooth, this one's knurled, but what it means is the outside diameter of the shaft is identical to this. So I may have a bit of a hard time adjusting the frequency dial exactly, because the set screw is obviously going to go inside one of the ridges on here, and there's no way I can do a fine adjustment on how this is oriented, but I think we should be okay because that's not really a precision the dial isn't a precision dial. So if we can get it to work, that'd be great. These pots were under $1. And there is one slight mod I'm going to do to the pots. And I'll show you what I do. So the replacement pot, of course, has the slot, the open slot here with access to the contacts. And what I do, and I really don't know if that helps a lot, but I do it anyway. I take a piece of electrical tape and put it over the open slot, like this. Oh, I gotta cut it short, but with the hope that that piece of tape reduces the amount of dirt and crud that gets into the pot over its lifetime. And again, I don't know if this really works or not, but the slot is closed, and it should help a little bit. Another thing we need to do first is this pot has an alignment tab over here. There are no alignment holes here, so we're going to have to get rid of that. And the material, the body material, is pretty brittle on those, so if you grab it and you go back and forth a couple of times, it comes right off. And you have to play around a little bit with spacing it correctly, but let me go ahead and do that and see what she says. Alright, so I got the pot in, and I'm not too happy with it. I mean, it does work. It's smooth, does the job. But mounting it was a pain. Remember, it has the knurled shaft, it has a split in the middle, the shaft is kind of short. Needless to say, it took me a really long time to get this to mount properly on this. And I can't get the this part of the dial to sit evenly on or near the front panel surface. I mean, it moves up and down, and I've tried like 5 times to put the set screws in, but I just can't get them in properly. So I'm unhappy with this. Even though it works, I can't have an instrument where the dial, you can't really see it from there, but let's see if I put it this way. Can you see? See how the distance between the front panel and the dial changed? That's just driving me crazy. So I need to find some better pots. One of the problems is also these pots are ultra cheap. When I installed it, tightened the screws and put it all in, the pot's actually unstable. I mean, this part moves, even though the bushing is screwed down tight, the back part moves. It's not stable, so I don't expect this pot to last very long, even in my lab. So finally I said, sealed pots be damned, and using some small screwdrivers and knives, I was able to pry off the back plate of the sealed pot. Now, in my opinion, this is not really a sealed pot, because once you take off this part, this is exposed to the elements, assuming that this gives you an airtight seal, which isn't always necessarily true, because I could get it off. Took a while, but I don't think that these tabs, that this whole setup would give you an airtight seal. A real sealed pot actually has an enclosure over the actual element, the resistive element. So even if this part comes off, it's hermetically sealed. But this one isn't. So is it a sealed pot or not? Leave me a comment if you know better, but it doesn't look like one to me. Anyway, So what I did was, now I had access to the resistive track over here, and I sprayed it with the contact cleaner, let it drip for a while, and see if we were actually able to fix this one. And so to do that, you can see I got it hooked up with clips right now. I'm going to put the back plate back on, hook it up to this pot, and see what the trace looks like. Alright, let's see. Looks like I cleaned it. Now the only thing, and I did this before, you may notice, is when I turn the knob and I let go, the frequency changes a little bit. I saw that before too. I've lubricated the shaft, I've done everything. I don't know if this is a mechanical thing but it works. I didn't show you what it looked like before, but essentially when you turned it, the screen went all fuzzy. The frequency was all over the place, and it was really difficult to do something. But see, you let go, and the frequency changes slightly. But once you let go, it stabilizes. It's not like it's pressure sensitive, or the shaft's going to get pulled in one direction or not. So this looks good to me. I think I'm going to crimp this back together again, install it in here, and then we can go for a final test on the function generator. Okay, that didn't take very long. It took me like 5 seconds. Put the dial back on, and it's straight, and it's fixed. I mean, you can see the effect of the frequency changing slightly when you let go of the button, but I'm willing to take that and have a non-wobbly dial on here. So, well, there's our triangle. Of course, our square and our sine. What we have is we can adjust the amplitude. Now we are in DC. You can enable the DC offset. Let's make sure that we're somewhat centered here. And so when we press this button, we can add a DC offset. And that works. Also notice it's not very jumpy, because these pots were just incredibly jumpy and scratchy. And let's see, so we've looked at that. Let's see if the low output works. It does. And next, let's go back to the high. So what other things do we have? We have a ramp out, and as you can see, that's a really slow ramp. Now that's not adjustable by this dial, but rather by the duration pot. And I think, yes, we can set the multiplier to 1K, and then that gives us a ramp, adjustable by this button. Next we have a TTL out. It also works, but and you set the big dial for the frequency, I mean, we're at 1 volt per division, so we're getting a 2 volt signal out of this. The manual states that it'll give you like a 3.5 volt output signal. That probably needs to be adjusted. And we'll have another peek inside. We didn't really look at the top of the PC board in there, but there are a lot of adjustments in there. Another thing to test, does the vernier control work? It does, but it has very little effect. So let's go to a higher frequency so we can better see it work. And then of course put the multiplier to 10K. End up with a really ugly sine wave here. Let's see. Oh, still the TTL out with quite a bit of overshoot and undershoot. That's not the scope. That is actually the function generator, which probably needs to be calibrated. But yeah, all of that seems to work, and the only thing remaining is the sweep function. And the way that works is turn on the sweep. Let's see. So here is the start frequency. And I guess this is the end frequency. And let's go really slow on this. And there you go. So let's go a little higher again. And you can see it sweeping. So it looks like all of those functions work. Our rotary controls work. The only other thing that we could probably look at is the control voltage out. And that, of course, when you're not sweeping, should be a constant DC value. But if we turn the sweep on, we should see the control voltage do its thing. And it does. So I would say it's functional, but needs a bit of calibration. But for audio applications, for some digital testing, I think this will do just fine. So back to the inside again. I mean, we looked at it briefly when I was pointing out the push buttons, but we can see a profusion of trim pots. There are a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 of them. Oh, these are hidden. But there they are. They're not labeled as to their purpose. I do have a user manual for this, but I do not have schematics or a service manual, so I don't know what the calibration procedure for this is. But we'll call it good for now. I think the best part of all of this was that I think throughout this episode I now lost my fear of taking apart sealed potentiometers, which is going to make things a lot easier for me on older instruments, which a lot of them use these pots. And again, solve the mystery for me. Is this a sealed pot or not? I mean, if you read up on it online, everybody calls it a sealed pot, but without a sealing element on the inside and just using the metal outer shell, to supposedly make it dirt tight. I mean, that in itself, and also there is a little bit of playroom between the shaft and the bushing. Things can get in there, as we saw, can get in and will get in. But looks like you can clean up these pots and get your instrument to work again. So finally, it would probably be a good idea to see what the frequency coming out of this thing is. And for that, I will be using this super modern Heathkit digital frequency counter, model number IM2420. I really wanted to do an episode on this, but all that seemed to be wrong with it was that the power knob was broken, because somebody went over enthusiastic on the set screw and broke the thing in half. So I put another button on here, another knob. Doesn't really match, but hey. So let's see what this guy outputs. So it's rated at a max of 3 megahertz. We are in the highest range, and the dial is set to 3 megahertz. So it seems to match the dial. Let's put it on 2. 1. 500K. So actually the dial is pretty well aligned for something like this. Then when we go to the middle setting, crank it all the way up, or leave it at 300, we have, so what are we? We are in megahertz, so let's switch to kilohertz. And we got 30K. And finally, multiplier of 1 gives us 309 hertz. So let's go back to the middle again. I mean, the update rate of the frequency counter is nothing to write home about, but at least it verifies to us that the frequencies of this guy are good enough. One last thing was, we didn't discuss the VC-in, which stands for voltage control in. And what you can do here is essentially slave 2 of these together. I mean, make one a slave. Let's say this is the master. We can feed the CV out to the VC-in on others, 1 or more. I haven't looked at the specs. I don't know how many others this would be able to drive. But then we could essentially, since this only can't output several waveforms simultaneously, by slaving a couple to this, we could make it output different waveforms at the same frequency. So there you have it. So there's the final product. 1 down, 3 to go, right? No, the others have the exact same problems as this one did. Dirty buttons, dirty pots, and I think one other one had a bad frequency dial pot. But I'm going to do the exact same thing to those that I did to this, and I guess I'll have 4 function generators. Thanks for watching. Please support the channel, a thumbs up, and subscribe if you haven't. And we'll see you with something interesting next time. Take it easy.